Welcome to Hancock's VMware Half Hour. And welcome back to another episode of Hancock's VMware Half Hour. Okay, well, it's a special one today. It's very special, and really my thanks actually basically goes out to you, the 2,000 subscribers that we've hit in the last couple of days, to this particular channel on YouTube. So my thanks for liking these videos, my thanks subscribing to these videos, and if you keep liking and you keep subscribing, we will keep producing Hancock's VMware half-hour videos. So anyway, thank you very much for subscribing, liking and watching. Okay, so that's the first bit of news out the way. The other reason why this is a special video, certainly for me, I have been tinkering, I think is the word, or certainly in Yorkshire we call fettling, doing, fiddling, hacking, cracking, whatever you want to call it, modding. I've been fettling away for some months, and by now you may know that I am a real fan of these little things. You may be able to see them there. These are Raspberry Pis, but they're not the standard Raspberry Pi 5. These are the Compute Module 5, Compute Module 5, the CM5. And these things are breeding around here. They're a bit like USB flash drives or CD-ROMs or floppy in the day. I just seem to have loads of them all over the place. We have loads of CM4s as well. Anyway, so let's just get on to what we're talking about. Okay, so Raspberry Pi Compute Module 5, released a while now, and of course shortly after the first release of the 1 gig, the 2 gig, the 4 gig and the 8 gig version, which sort of kind of replicate the original CM4, the Compute Module 4, and the standard Pis. There were rumors that there was going to be a 16 gig version, and the 16 gig version is now readily available in both Compute Module 4 and the we'll call the original version of the Pi 5. Now, unfortunately, like always, several changes have happened in the delivery of the Broadcom chip. We'll call it the CPU or the SoC, and that's the introduction of a new stepping. Now, if you look at the center of that silver can in the middle there, and if you look at the very end, you will see it says B00D0T. Now, D0 is significant because it actually basically it highlights the fact that this is a different stepping. Now, steppings are quite common in CPUs, Intel CPUs and AMD CPUs, where we use the term stepping. And now with Raspberry Pi, we see a slightly different generation of the chip and the die. And you can look at Jeff Gerling's site. I'm not going to go into the details. He's documented it quite well. Well, he's documented it very well. That's just, not just well, he's documented it very well. The differences between the previous versions of the Raspberry Pi SoC and the latest versions. However, if you're I think if you're probably purchasing a new Pi now, certainly I think in a 1 gig and a 2 gig version, and most definitely in the 16 gig version, you will find that it has a D0 stepping. Now, this is really unfortunate for us with using ESXi ARM, which is what this video is all about today. It's about the ability to get ESXi ARM, and just let me bring that in. Okay, so here is a Raspberry Pi CM5 with ESXi ARM 8.03C installed. As you can see there, it says 16 gig. It's running the ARM Limited Cortex A26 R4P1. So I've been working with this for about the last 4 weeks. in the fact that I have now managed successfully to install ESXi ARM onto a CM5 with 16 gig. I could have used an 8 gig version, but I was really interested to see that obviously the 16 gig version gives us a lot more virtual machines, or virtual machines that have got larger memory footprints. But we were somewhat limited. Unfortunately, the original version of the UEFI code on GitHub, and if I basically just go and get a browser and do CM5 UEFI, and I can show you that. I will come on to installing it, by the way. So if we have a little look at the original project that was on Git. So I've been looking at this end of last year and the beginning of this year. I was away in Malaysia in January and February when I stopped looking at this, and sadly the RPI 5 UEFI was archived, and effectively there had been no updates on it, I don't think, until about March last year, 2024. And in February the 5th, 2025, it was archived. And there was a notice basically that sort of kind of stated, I think it's on here somewhere, that it says here, the firmware provided here has only been tested on early Raspberry Pi 5B models. It doesn't work on the CM5. And then the recent D0 models broke it completely. Which was a bit of a disappointment, really, because I really wanted desperately to get the CM5 running on. I'm just going to go over here. Sorry about this. Should have been more organised, really, to be honest with you. Oh, I was going to say a bad word, but anyway. So I'm really desperate to get the CM5 working, and I'm just going to give a plug out for Ivan, really, at Compute Blade. Uptime Industries, that I'm going to say he's dedicated his entire life to basically sorting out the compute blades. I'm going to give him a plug. He deserves a plug. So there's a compute blade. We've got a few here in the lab. This currently has a CM4 on it. So effectively, you can have an NVMe stick and AI modules and all sorts of stuff. It's PoE, fits in a lovely 19-inch blade enclosure. Anyway, our end goal eventually is to have 20 of these in a rack, in a self-powered rack, if you like, with nice SCSI SAN, with a switch that makes it all containable, so that we can basically drag around to VMugs for a laugh. I was going to say another naughty word then, but I do have to be careful. Anyway, so that's the goal. Unfortunately, the CM5 Raspberry Pi UEFI, nobody was really interested anymore, and it got archived. So that really actually basically made me even more enthusiastic to try and get ESXi ARM, because we actually basically need the UEFI bootloader to install ESXi ARM on the CM5, and the old version of the UEFI code basically didn't work. So after a bit of fettling, we managed to get it to work, and this is what this video is all about. How you can install ESXi ARM on a Raspberry Pi 5. We'll say a current Raspberry Pi 5, because of the early versions of the Raspberry Pi 5, you could do this. But as I said, with the D0 stepping, that busted that. And if you actually basically want to try a 16 gig CM5 or a 16 gig Raspberry Pi, then you can follow this video and you can do the same. I've not released the code that I have into Git, but since I've been fettling with this in the last 4 weeks or so, in the last 5 days, somebody has published code code changes now onto Git that you can download, and we're going to do that today. I'm going to have a little look at his code, because I think that his code is a little bit more advanced than my code. But again, as I said, I'm just a fettler. I'm not a developer. You know, I'm a hacker, cracker, fiddler, and a fettler, not a dev. Anyway, so that's what we're going to do in this video. So apologies for all that waffle for the last 10 minutes. So now let's actually basically get in to what we're going to do. So the first thing I actually basically want to show you is I'll put this link in the description, so you can go off basically and download RPI5-D0V1, which is a zip file. And then quite simply, all you want to do is basically unzip that zip file, copy all the contents to an SD card. Now we do some funny stuff here in the lab, because we basically do boot from TFTP and Pixie and all that sort of kind of weird stuff. And I have covered that in one of our very long videos. It's about an hour in how we do all that stuff. But today I'm going to make it simple. And I'm basically just going to copy and bob it onto a micro SD card. Now there is one change that you want to make. There's a config.txt file that contains frame buffer underscore depth equals. Now, if you set it for 32, you're going to get a black screen when you boot. And you're going to think to yourself that it's completely crashed and it's not doing anything. Well, it is. It's just that there have been lots of changes made between the D0 stepping and I think the C0 and the C1. And I think the result really of the D0 stepping is to make the die cheaper to produce. I think they've chopped out an awful lot of stuff that was never ever needed, was never ever going to be used. So ultimately the D0 stepping of the Raspberry Pi is a cheaper SoC to produce than what it was previously. Anyway, so there are some still compatibility issues that are around, and one of those is the frame buffer. If you've got frame buffer equals 32, you're going to get a black screen most definitely. So you want to change frame buffer underscore depth equals 16 or 24. And same thing happens in the mashup code that I had a little look at. I've got the same issue with mine. But if you have a little look at the one that I've got here, you will sort of kind of notice, if we just go back to the camera here, yeah, if you have a little look here, it actually basically says Raspberry Pi Foundation unknown, Raspberry Pi model, etc. The code we're going to look at today also basically addresses that issue as well. So, following, download the zip file, unzip the zip file, bob it onto a micro SD card, change frame buffer underscore depth equals 24 or equals 32, change that to 24, save it. Then basically eject your SD card, micro SD card, bob it into your Raspberry Pi in whatever way that you're doing this. If you've got a standard Raspberry Pi, then basically you can plug it into the socket. If you've got a CM5, then you're going to have to do some slightly other different things. You're going to put it in a daughter board or something else basically to be able to write to that SD card. So just let me pause this because I'm going to go and remove the SD card. I'm going to put it in our dev board. Yeah, as you can see, I get this really horrible. This is the frame buffer. As I said, the frame buffer still not perfect, but certainly now that this has been released back onto Git, as I said, it was a real shame that the old project was archived, so nobody could actually basically work on it, which actually caused us some issues. But now that somebody's actually basically forked it, changed it, put it back onto Git, it's hopeful that we'll get more people in the community basically to work on this and expand the UEFI code and fix some of the issues that still exist. Sadly, there's still a big difference between the CM4 UEFI code and the CM5 UEFI code in terms of functionality. It still doesn't have iSCSI, and it still doesn't have Pixie, and it still doesn't have HTTP. So it supports the very basic of boot functions. Okay, so I'm going to shut down and restart this ESXi host. I'm going to do F11. We have an NVMe stick in this CM5 dev board. We've got a USB flash drive that's basically currently connected to it. So we're going to do a standard installation. As you can see, the frame buffer there is just a little bit different to what I'm using. You can actually basically see that there's a slightly version difference change as well. But we've got 2.5 gig, 16 gig. So I'm going to select Boot Manager, and I'm going to select our Kingston Data Traveler because that's got the ESXi ARM installer on. So this is just a standard ESXi install. So we'll wait for this to boot. I'm going to drink my double espresso out of my lovely Fangfoss pottery mug. It was an open studio last weekend, so we had the opportunity to bob around all the local art studios and have a little nose what they're doing, and also buy some trinkets as well. Anyway, so as you can see with this code, it actually recognizes that this is a Raspberry Pi Foundation Raspberry Pi Compute Module 5 Lite. It's the Lite version, so it doesn't have any eMMC. And to be honest with you, really, personally, I wouldn't buy any Pis that have eMMC. I think that's a lot more flexible if you've got a micro SD card than embedded eMMC module. And my understanding is that the data lines for the eMMC module are exactly the same data lines as the SD card. So it's one or the other, not both. So there are questions around if the eMMC chip died, burnt out, wore out, actually on board the Pi, then, you know, you'd end up basically with a brick. You wouldn't really be able to do much with it. You can't plug an SD card into those devices and get it to boot from them. You'd probably reprogram the bootloader that I do to boot from another source like network or something like that. Anyway, so I'm going to have a swig of this. This is basically going to welcome us to the ESXi installer. You would have seen this before. If you've done installations before, then you would have seen this. So I'm just going to, yeah, I'm going to do F11. Now, I'm not really looking at the screen here because I've done this so many times, really, to be honest. I know really what to expect. But here you can see that we've got an NVMe. I'm just trying to think what I did with the boxes. Crucial P3 Plus PCIe for NVMe, cheap as chips. Brilliant little devices, really, for the lab. So I'm going to install on our NVMe device. There is actually already an installation of ESXi 8.0.3c on it, but I'm just going to overwrite it. So I'm going to say, I know what, let's just do preserve VMFS data store. Nah, I know what, let's just say overwrite, followed by enter. US default. I'm getting confused because I've got two keyboards here. Yeah, that's going to erase that. So let's do F11. That looks a bit better. Before, basically, I got an assertion error for whatever reason. As I said, this is a tech preview. It's code that we've downloaded from GitHub. You know, so this isn't production from Broadcom. It's not production from Microsoft or anywhere else. So, you know, in the home lab, you know, we're going to expect these little things. But I've not really had any problems with the stability of ESXi ARM. And I've been using it really since about October, November 2020, I think it came out. Okay, so with that, I'm going to hit enter. I'm going to reboot. And I'm going to get another espresso again. It's a funny day here today in the United Kingdom. It's very overcast. It's very cold. Bees don't really know what they're doing. I don't really know what they're doing either. And they're a bit all over the place. So yeah, it's about 14 degrees C today and windy. It's very, very cold. You know, I even had my woolly hat on earlier and a coat whilst I was out walking on my on my lunch break. And as you may have noticed, I'm now in my spring plumage. I've chopped all my hair and chopped all my beard because it was just getting too hot in the bee suit. And I could tell you a story about being given some money whilst I was in Edinburgh because people actually thought I was a vagrant when I was sat on a bench. Anyway, we'll talk about that another time. Okay, so it's all looking good. Raspberry Pi Foundation, Raspberry Pi Compute Module 5 Lite, ARM 16 gig. Okay, the screen is not grey over yellow. My apologies. I was told the other day that it was gold. I always thought it was yellow, but it's grey over gold. But anyway, doesn't look like grey over gold. But, you know, how often really are we actually basically looking at the hypervisor screen or the ESXi hypervisor screen, really, to be honest with you, with VMware vSphere hypervisor? Not a lot. You know, all my Pis here and CM5s, you know, they're all completely headless. So I think I'm done with that keyboard. So I can basically just put that there for the moment. And I'm waiting for the big reveal. So this is VMware ESXi 8.0.3 VM kernel release. When it appears there, 8.03. It's gone black a little bit longer than... Ah, that's interesting. That's interesting because that's actually booted the installer again. Now, that might be my bad because I didn't actually basically remove. So let's just get that keyboard. I wasn't watching properly. Let's just do a escape. See what I'm going to do? I'm just going to remove power and I'm going to unplug that USB flash drive. Right, okay. Let's pay attention because it should just boot from the NVMe stick. That basically just booted back. I wasn't paying attention. Yeah. Okay, so build 24449857. So hopefully, just like any other ESXi installation, whether on Intel or whether on ARM or whether on AMD, eventually this is going to boot up with our imaginary grey over gold DCUI, and then basically give me an IP address. Hopefully the IP address should be the same as it was before, and then we can basically log in with the HTML client. We can have a little look at the version information. Now, there is one other thing that you will need. Sadly, again, and it's possible in the future, we can only keep our fingers crossed. Now that there has been some momentum with the UEFI code, that we can actually basically now boot ESXi ARM on a CM5 or a Raspberry Pi on the 16 gig version. So there we go, 16 gig memory, ARM limited Cortex A76-R4P1, Raspberry Pi Foundation, Raspberry Pi Compute Module 5 Lite. I just want to basically make a note of this again. This is a tech preview. It's not a product. I think I know what the IP address is there. So let me basically just fire up my web browser and go to that IP address. Anyway, as I was saying, there is one thing that you aren't going to need. And I'll tell you what, we'll turn that off, and you can actually basically see the lovely VMware ESX on ARM Fling, and I'm going to log in. Hopefully the password will be right, because otherwise we'll be completely knackered and I'll have to do a reinstallation. So I got the password right, and this is the familiar thing: help us improve the VMware host client, join the program. Yes, please. So we're currently in ESXi in evaluation mode. The license will expire in 180 days. Yes, we get a 180-day free license on ESXi ARM. So if you don't have a valid 8.0 license, then you're just going to have to reinstall. I've not tried the ESXi free license. Hang on, just one moment. I'm curious here. Just one moment. What do you know? I thought it might. The ESXi free license from 8.0.3e also actually basically works on VMware ESXi 8.0.3c on ARM. So there you go. Rewind a bit. You don't have to reinstall every 180 days because Broadcom have given you a free license for ESXi 8. I'm not going to publish that. I know that ESXi free key certainly is available out there in the wild. I've seen it. But that doesn't actually basically give me absolute right basically to publish it here on YouTube. But just as a thing, if you already have the ESXi 8.03e license key, which you'll find because it's embedded when you install it now, you can cut and paste and put that in ESXi ARM and it works as well. Anyway, so I just really wanted to end by sort of kind of saying, if we look here, Raspberry Pi Foundation, Raspberry Pi Compute Module 5 Lite, 4x CPUs, ARM Limited Cortex A76-R4P1, 15.98 gig, which is really what I wanted to show you, that we are using a 16 gig CM5, and the image profile here, ESXi 8.0 U3C, build 2444957. I think I said 8 before, it's a 0. And finally, one other thing that you will need, again, the CM5 has changed. We already know it's changed because we now have a D0 stepping. But even in the previous version of the CM5, again, they tinkered with it and they changed the network interface card in it, which effectively means that the only way currently that you can actually basically get a CM5 or a Raspberry Pi, I think, certainly a CM5 because I'm using it here. The only way that you can actually basically get networking into a CM5 is by using a USB network interface. So that's how I'm doing it here. Yes, I'm in fact using two. I'm using one to bootstrap it, and then I'm actually using the other one basically, which basically has got the VM kernel in. Because if we actually basically have a little look at networking here, and we have a little look at physical NICs, we can only see one, which basically is this one here, which is the USB. We can't actually see the network interface, which is actually internal to the CM5, unfortunately. But who knows what changes are going to come in the future. Now that we've actually basically got a working UEFI in version 1 for the CM5 or for the Raspberry Pi 5, it may allow further development. So I'll post the GitHub reference in the description. I'll post a reference to the device. I've got the box here. I think this is the box. Here we go. I've got the box here. If you want to try this at home in your home lab, then all you need really is a Raspberry Pi. Could be a CM5. It could be standard Raspberry Pi 5 with a D0 stepping with 16 gig. You're then going to make sure you buy the SD card model. Don't buy the one with the MMC. You need a micro SD card. You need the link. Extract the contents. Bung it on a micro SD card. Don't forget to change config. Change that frame buffer to 24 from 32. Boot. You'll need a USB stick basically for your ESXi installer. I'll put a link to that fling in the description as well. And you will need a USB gigabit interface, and the one that I'm using here at the lab is by TP-Link. These are cheapest chips on Amazon, and I'll put the model number of this. It's actually a TP-Link UE306, so that's what you need to look for on eBay or Amazon, and their cheapest chips are about £5, I think. Okay, so all there's really for me to say is, again, thank you very much for watching these videos at Hancock's VMware Half Hour. If you'd like this video, then please give me a thumbs up. If you don't like these videos, then tell me why you don't like these videos. Don't forget to subscribe, and don't forget to come back for more videos created by me, Andrew Hancock, at Hancock's VMware Half Hour. So with that, I'm going to disappear. I'm going to finish off my espresso. Good afternoon to you. If you've got any questions about ESXi ARM or anything VMware related, really, then please drop them in the description. If you've got any requests for other videos, then please drop them in the description. I am slowly going through the list, and I still got so many more videos that I need to edit and I need to publish. Sadly, there's just 24 hours in the day, and that's all. Again, anyway, so thank you very much for watching, and good afternoon, and goodbye from me. Thank you. Bye bye.